Ensure you have selected the right speaker for audio output. Test your speaker to ensure it is working fine from the audio settings option on the lower left corner of your screen. If necessary, dial in using phone.
Hello everyone, I'm Umesh, host for today's webinar. Thank you for joining us in the first episode of our exciting series on cloud. I welcome you all on behalf of Harbinger Systems. This will be about 45-minute session with last 10 minutes we'll take some audience questions as well. Feel free to type in your questions in Q&A box. Getting your cloud right series promises to cover all the important aspects of cloud, whether you are adapting to cloud, migrating to hybrid environment, or optimizing it. However, most importantly, getting it right the first time itself is going to be the focus of our very first episode today. Today I have Abhijit Gokhale, Senior Architect, Harbinger Systems with me. Abhijit heads Center of Excellence that focuses on cloud engineering and HR tech practice. He has more than 11 years of experience in enterprise application design, and he very much possesses hands-on expertise in cloud computing, performance, data security, and system integration. Welcome, Abhijit.
Hey, thank you, Umesh. Looking forward for our engaging discussion.
Glad to have you today. So, Abhijit, cloud technology has been there for more than a decade now, right? And while many new products were born in the cloud, others are in different phases of their cloud journey. They may have completely migrated or using hybrid cloud environment or have just plans to make move now. However, just simply operating in the cloud isn't enough, right? You need to make it more robust, scalable, secure, maybe compliant, and investigate all such significant aspects, right? And also, products are constantly innovating, right? I mean, they are leveraging new technologies. There's big data, BI, AI, blockchain, so many things, right? And everything requires cloud underneath and require much deeper considerations for doing it the right way, right? So I think doing it right has always been important, hasn't it?
Absolutely, Umesh. So we are at the stage in the evolution of cloud computing where infinite scalability, high availability, ability to deliver quick and frequent enhancements are taken for granted by everyone. Now, in order to meet these expectations, we need to ensure what more should be done to ensure that we deliver it we do it in right way. So if we look back also at the history of software engineering, we will notice that at every stage, whenever a new expectation about the quality of a software has emerged, the software engineering community has stepped up to ensure whatever was necessary that was done in order to do it right. So the processes, methods, tools, patterns, and practices has continuously evolved to improve the ways in which we kind of deal with all the phases of software product engineering.
Right. I think you're going back to history. Then in this context, how do you view this whole evolution of the software engineering, the cloud area, in the more of cloud era?
Sure. And for that, let me give you a couple of examples from the history itself. So the first one, after the emergence of object-oriented technology, everyone was started talking about the reusability and the resultant speed of development. So in order to address this expectation, design for reuse was something needed. And we all know the famous Gang of Four Patterns book kind of played a vital role in providing that particular direction. And then the frameworks, the programming languages, soon started following these ideas. So this actually impacted the way we develop the software. It also helped to develop the software faster, along with addressing the reusability expectation. The second example I can think of is the way we handle the customer requirements. So we have transitioned from the waterfall, spiral, iterative type of a model to the agile type of a methodology now. So what it has done is it actually enabled the customers. So it has enabled the customers to understand how their requirements are getting delivered by us as well as from our point of view, it has enabled us to capture the frequent feedback from those customers. Now, if we look at these two examples, so whenever these changes has happened, the dev teams was kind of growing larger in size. So along with that, the processes like whether it's a software development, testing, integration, deployment, all these processes got stronger to deliver the right software along with the speed which was needed. Even the tools like the version control, build and deployment, which we now refer it as CI/CD tools, they have kind of evolved to work together to provide that speed, not only from the development, but along with the users of that software. So if I put it in my opinion, I would say the cloud era has evolved over the last decade, and the changes that has come with it, we need to look at those very closely in order to identify the ways we can do the things right. And while doing that, one point I would like to make is we also need to continue to adapt the good parts of the older best practices.
Absolutely. I mean, very true. This whole agile, faster development and deployment as well, all driven by this continuous pressure to innovate rapidly, right? And all this has forced us and as a developers to wear that operations hat and make many choices about maybe deployment of their components and services. So what would be more important aspect for developers now that are more critical as far as the deployment view of the product is concerned?
Sure. So if we talk about the deployment architecture of a software, then we will notice that it provides two types of information. The first one, the runtime organization of the components, and the second one is the computing resources allocated for those components. Now, if we try to map it in terms of the products which are hosted in the cloud, then one important aspect we will notice that the infra aspects of the deployment is actually completely owned by the cloud providers. So they are managing it. So, and even like the compute choices, if you look at the various options which are available, whether it's virtual machines, containers, clusters, or even to function as a service, along with that, we can also notice that, let's say the event management or, these type of services was provided, like these type of mechanisms are now being provided by the cloud providers as a services. So this has whole resulted in cloud provider taking responsibility of such many components on their hands. So this actually impacted the role in which the IT team, has worked kind of traditionally. So developers coming closer to operations has happened. And along with that, the manner in which we kind of do the operational monitoring of our products in terms of performance or availability, etc., we also need to adapt to those mechanisms. So if I continue talking about, let's say, function as a service, in terms of abstraction, if we look at it, then we will notice that we just have to focus on the logic within that function. But we don't have to worry about the context from where that function will be invoked. So for example, it can be invoked from a message getting passed to the queue or a file getting updated. So even though the context is distributed, the abstraction remains same. So what does this mean in terms of doing it right? So now let's try to understand it based on some non-functional aspects of it. So since we were talking about the functions, we all know that the functions are nothing but they are part of the bigger task that is getting accomplished. So in that context, doing it right means, or rather it also includes the right error handling, ability to retry or recover from the failures. So we all know that logging the information is critical, but along with logging the good information, context also becomes equally important from the field debuggability point of view. So if I say the performance point of view, logging the performance information in the context of the action being performed by the user will make more sense. Now, we have the simple metrics available, which are kind of provided, readily provided by the cloud providers. But then these metrics will not help us in establishing the correlation. So it cannot determine the correlation of a function performance against the action which was performed by the user. Another example I can think of is like the cold start versus the warm start also. So here, the cloud provider is kind of telling us that there will be a delay in the first invocation of a function. Also, if the frequency of invocation, let's say it gets reduced, then we may observe similar set of delays for subsequent invocations also. So this actually kind of put in our shoes, wherein we have to come up with our own strategy for handling the warm start of the function. And while doing so, we also need to look at the other aspects like cost. So I would say understanding these various aspects is crucial for doing it right based on the choices that we make. And if this type of information is available with the product team, they may be able to achieve it at first itself. But if it is not available, they may have to learn it in hard way also.
Okay, yeah, and this is getting interesting now. So you rightly brought the whole architectural view to describe this whole change happened in the whole process. Maybe if there are some examples more where typically there is a transition from a legacy system to adapt to a cloud now. So are there any some examples to share here?
Sure. And since we talked about the deployment architecture view itself, now let's look at how that view can help us in that particular transition of getting adopted to the cloud. So we all know that the architecture of systems, earlier we used to refer it as whether it's a layer based, message based, component based, so on. So if we talked about or look at the layered architecture, we know that the logical view provides the separation of concerns. So it actually separates your presentation, business rules, and the data management part of it. And the same layered architecture, if we look at from the physical or deployment view point of view, then that is nothing but our classical NTR model. And such architecture, we used to handle the scaling requirements by adding the number of machines and by adding a load balancer at the front. Now let's consider organization having such application is getting migrated to the cloud or moving to the cloud. So the deployment architecture can be a good starting point, because with that we'll able to identify the components and we'll able to map those with the services within the cloud also. So a simple mechanism would be a direct mapping of those components to the compute infra provided by the cloud. And while making the choices, either we can go with the same configuration or we can go with the higher configuration, depending upon the need. So this strategy we can call it as a lift and shift type of a migration. But just one point to notice, let's say in the pre-cloud users, if the resource utilization is not as per the expectation, then even after moving to the cloud, we will not see any cost benefits. So having the good users data for the longer period of time becomes critical, so that we can make the better choices as part of the cloud migration process. So if we are actually capturing the usage or the load data, even the load or the resource consumption, that is going to add a value while making the choices as part of the cloud migration. So overall, I would say if such data is not available for the planning, then at least we have to make a provision. When we are moving it to the cloud, we need to make a provision and we start capturing this type of a data at the required granularity, so that we can, moving forward, we can pass this information to the DevOps team and they can actively adjust the resource needs.
Okay. So with the presence of now multiple cloud providers and they provide availability across globe, guarantees that based on subscriptions. So is there anything more for us to do in general overall managing the availability here?
If I want to answer in a simple word, then I would say yes. And even the recent example, if we can take a couple of days back, we all know there was some downtime from one of the cloud providers, and
Right.
major applications were affected by it. So let's try to understand like what provider guarantees, and from the application standpoint, what we need to also address. So from providers' point of view, definitely, since they manage they provide the services, they are going to manage the availability from their end as well. And how they do it in terms of the SLAs. So as part of the SLAs, they provide the uptime guarantees and the compensation if they don't meet those requirement, and that is also in terms of the credits. So let me simplify by taking one example. Let's say uptime per month is below 99.5%, but it remains above or at 99%. So in such scenario, provider may say that they will give up the 10% of a credit. But if we look at this example carefully, we will notice that from the provider point of view, they are fully meeting the SLA as long as they are supporting the 99.5% availability. So that means if we do the calculation, roughly around 3.6 hours per month, we can expect a downtime. Now, if that downtime happens on a single day, which happens to be a very busy day, then we can imagine what impact it could have on the business.
Very true.
So the point here would be like the dev team needs to understand these SLAs, take into consideration, and derive their strategy for availability by considering these factors. So in terms of the strategy, I would say there are three aspects to the strategy. The first one is strategy to kind of monitor the failures. The second one would be how do we recover? And the third one is to prevent the failures. So we do the handling within the application, but that won't be good enough. We need to take one step further and we start monitoring the cloud services which are getting used. And for that, we can make use of the monitoring agents. A simple approach could be try a kind of a retry or a recovery mechanism, perform this type of action if the failure is detected. If we are not able to do the retry, then in that case, we can simply see if we can still make the application available by keeping some part of the application or keeping some features down. So logging error information is also critical, and along with logging, notifying that information to the operations, with that will able to provide the quick resolution. In terms of other strategies, we can also talk about the application redundant strategy. So the classic example could be the database cluster for the high availability point of view, or even from services point of view, we can think of deploying those to multiple availability zones. So whenever we make any choices, there will be the cost implications. But depending upon the nature of the application and the impact of the downtime it is going to have on the users, we have to make those appropriate choices. So as long as we discuss these failures of cloud components in the applications and decide the availability strategy at product and business level, that is something important, I feel.
Very right. And as we ensure availability, the next obvious thing to consider is it fast enough? And right. While talking about functions as a service usage, you mentioned about paying attention to service specific constraints like cold start duration or serverless function configurations. Now, if you can tell us more about the performance engineering strategies that needs to be adapted for the
cloud. Sure. So one thing I feel is like if we continue to focus on the fundamentals and apply these elements to the architecture, that helps in the development as well as the post deployment, and it also brings in the required good performance. Mm-hmm. So if I talk about the performance from the user point of view, if we look at it, then from the user point of view, it would be like how quickly an action is completed by a particular product and the result is displayed. Now, the user action generally consists of multiple concurrent requests. So that way, the actual time, if we look at, it is going to be when the last response was received. So the total time is the summation of time taken by the individual component as well as the data transfer time between these components. So the first important thing would be to measure the performance at the different level of granularity. Okay, and that is depending upon our need, we need to decide. So, and if we look at the deployment architecture with a high level of abstraction, we'll able to capture a couple of points. The first one is the compute resources and the entry point of the request. So that helps in measuring the performance. So cloud providers, as I said earlier, provides a ready matrix, which is a kind of a individual metric available, and it also provides a statistical charts of the performance. However, this is at very high level. This is not going to help us in identifying a particular component which is actually contributing to a bottleneck. So in such cases, we have to actually use the instrumentation of the code at the right place, which will give us the better insights. So if we start actually introducing the measurements within the applications, and if we start mapping the individual components time to find the user action time, and if we do that during the development stage itself, then we put good efforts at the first place itself. Also, the design time focus on performance is something very important, because that will help us in mapping the performance number to the user action itself. And once we do that, we will start able to allocate the time which is required for a particular component, because that way those component will be eventually part of the overall request which is getting delivered to the user. So with this strategy, team can start logging the performance or the processing times at the required context at the chosen granularity. And this information will help us in quick analysis and the identification of the bottlenecks. So I would say if we are able to allocate the time to a particular component, then we'll able to test that component individually for the performance using some automated test. And this way we'll able to identify the bottlenecks as early as possible.
Okay. So we talked about services optimization from performance perspective here, but it also has a cost implication. And naturally, the next business critical aspect is the expenditure management. And often these costs are realized later as we continue to support the growing usage of the services. So maybe if you can briefly touch upon how efficiently we can be ready for cost implication, and maybe is it possible to do it right at the design stage?
Sure, definitely. So in our earlier discussion, we touched one aspect of the cloud provider where we saw they have made it easy by taking the complete ownership of the infra management. So by taking that particular responsibility. So similar to that, they have also provide, or rather they provide pay as you go model that helps the innovators to get their innovations up and running quickly with low initial investment. And if we look at this pay as you go model, what it implies is payout every month, but that will depend upon the resources that you consume within that particular month. So that way we are saying in order to manage the cost, we need to manage the resource usage effectively.
Okay.
Now we can see it in two ways. I would say it can be seen as reducing the overall resource requirement, or even choosing or going with the less expensive option. Okay. However, in order to optimize a resource use, first of all, we need to monitor it. Okay. And so in the performance discussion earlier, we did talk about ready metrics being available at the cloud provider end to see the resource usage pattern. So that becomes a good starting point. Let me give you one example. So one of our own product, which kind of uses the machine learning models and AI-based solutions, the nature of the problem needed the GPU-based computation. So we ended up allocating such high-end compute for the AI component. But the other components of the architecture were kind of hosted separately, using the other compute resources. However, the operations expense management brought the questions about the cost. So we started the analysis. At high level, we looked at those ready matrices. Now looking at those, it suggested that all the components are actually getting utilized correctly. So they are kind of reasonably sized. So we then went further and did the kind of the fine grained analysis of it. And we tried to understand the usage pattern. So from that analysis, we observed the AI component, which was actually kind of running on the high-end compute, that was not using the entire resource. So it was having the availability wherein it can do the further processing on top of the AI task, which it was already carrying out. So this way, like, we have to go into the deeper of it in order to identify like which is the area which was, or rather where, which component we can reduce the cost. So what we did is eventually we kind of shifted some of the components to this high-end compute for reducing the cost. We also continued to monitor this resource usage pattern, further to kind of optimize it. And this resulted in two parts. One is the per user cost, I would say, got down eventually. And it also helped our product team to kind of forecast the cost if the usage increases. Okay, so the point which I would try to highlight over here would be the cloud usage is kind of maturing and the focus is on the upfront estimation of the cost. We know that the cost calculators are available or those are kind of provided by the cloud providers. However, one should be knowing the deployment architecture as well as the available services in order to make them make the use of those calculators effectively. So like overall, if we are able to identify the different deployment architecture choices, as well as if we are able to, let's say, predict the load for few quarters, with that, we can give a good projection about the cost. Also, I feel as an architect, based on our past experience of resource usage for different workloads, that comes handy while estimating the resource usage for different kind of the future deployment architectures, and will able to come up with the reasonable estimations in that case. And if we continue this process along with the continuous monitoring of the resource usage matrix, so that we will able to establish a good cost management discipline.
Very well said, Abhijit. I think there is a lot of groundwork involved, and definitely the deep experience with cloud platforms matters a lot here. So I think we covered some very remarkable aspects here, and maybe let's pause for now as we already have some curious questions waiting here. So before that, let's take a quick poll that will even maybe help Abhijit to respond to some of the audience questions better while answering some of those points. Okay, so there is the first poll question for you. It's a multi-choice answer. It's a single choice answer actually.
Yeah.
And we'll give about 10 more seconds for you. Okay, we have some responses now. And I'm closing this one and moving to the next. So this one is a multi-choice option for you. What's most critical at this stage of your cloud? Is it performance, security, availability, cost, monitoring, and observability? Maybe if there is something more, you might want to post it as well on chat. Okay, interesting. And cost is definitely always the concern. And the last one. Which of these areas you primarily would need to scale up your team? Is it primarily on the application development in cloud native technologies, or managing your current production, scaling up with the DevSecOps, or in general optimizing the cost and the current cloud architecture? Okay, and we have the responses captured here. Okay, all right. Thank you for your responses on these poll questions. And let's take some audience questions quickly. Based on that, maybe Abhijit, I think let's pick up the topics accordingly. And I see interesting one in the vendor lock-in topic here. So the question is about what would be your strategies to avoid vendor lock-in for selecting the cloud services?
Sure. So I think there are multiple ways in which we can look at it. But in my opinion, the one way we could do is while designing the application, we design it to be loosely coupled, and along with the consideration that it can be easily portable. So we can think whether we want to containerize the application from the portability point of view. That is one. Even we can take it in the context of the multi-cloud type of a strategy, where we then able to select a particular service from a particular provider. Also, I would say like the implementation of the DevOps tools and processes. So that is something important so that we are able to automate end-to-end deployment of the application. But while doing that, we can also ensure that we are using the technologies for the DevOps part, which are kind of cloud agnostic. So an example could be like leveraging the Terraform templates for the infrastructure as a code.
Okay, good. Next question, let's pick up about the cost, since there was a good amount of response towards cost as a concern. Are there any best practices for cost considerations when you are opting for infra as a service purely?
Okay. Okay. So in our discussion, we did talk about monitoring the compute users resources, how it is playing a vital role for providing the good insights, and that will definitely help us in making the better choices for the cost as well. So from the purely of the infra as a service point of view, the one aspect is the right sizing of those compute resources so that those doesn't become the underutilized. That is one. The second one is like cloud providers kind of provide different plans. So for example, like we have the on-demand instances versus the reserve instances. And if we actually compare these plans, we will notice that the reserve instances are kind of cost effective compared to the on-demand. Along with that, the one example I can think of from my earlier project wherein there was a need for the non-production loads, mainly for the dev and test environments, wherein the the infra resources has to be made available during a specific time period within a day. So what we did was we kind of did a automation script which used to turn on these resources at every day at the start of the day, and similarly it used to turn it off towards the end of the day.
Okay. Yeah. Let's take one last one maybe. This is about traceability. So how do you plan for monitoring microservices for traceability? What can we talk about?
Sure. Yeah. So I would answer it in the context of like logging is definitely an important aspect. And by logging, I would say not just logging the good information, but even the context, becomes important while logging the information. And it depends upon specifically for the microservices, if we have deployed it using containers, or in case we have deployed it using functions. There are services available provided by the cloud providers, which can be used for the aggregation of the logs, as well as making some insightful analysis from those logs. So from that standpoint, in case, let's say we just want to map the user session end to end, we can create a correlation ID, and throughout all the services that we have, throughout all those microservices, while logging the information, we also ensure that the correlation ID is also getting logged, so that using that, the traceability could be determined.
Okay, great. All right, I think we should probably stop here. Thank you for interesting questions, but maybe due to time limit, we'll address rest of these offline. And I'm sure all of you enjoyed this session and it was insightful for you as well. We touched upon some many aspects, doing it right the first time. And I'm sure you got some key takeaways to start on it. Before wrapping up, let me quickly talk about Harbinger Group. We are in business for about last more than 30 years now, and having a customer base across the globe, about 850 plus employees, primarily in India, and operating in dual shore with US customers primarily. And the Harbinger Systems is the tech services arm of the group, which focuses on end-to-end product engineering for HR tech, ed tech, and health tech verticals. Our product arm offers innovative products in the e-learning space, which are integration-ready products for educators. So Raptivity is a embedded interactivity, or rapid interactivity generation tool. Quillians is a AI-based question generation utility, and even we have a skim through, which is the video summary using the AI technology. We also have our content services arm, which focuses on custom digital learning and content transformation solutions as well, and helping transforming your legacy content into a modern interactive learning content. So thanks for your time today. Thank you, Abhijit. It was a very interesting conversation with you. And thank you, everyone. Stay tuned for the next episode.
Thank you, Mesh. Thank you, everyone, for joining.